Good morning. So, hopefully you watched my last video so you know what's going on with this utility disk thing. So, I don't have to cover that again. Trying to break up these videos into slightly smaller chunks. But I want to talk about where we're at with our little role-playing game. First, let's see where it's at today. I've done a bit of work since the last time we developed this. But you can see we have our little player walking around the whole town map, which I finally figured out how to get working, and the enemies. Every tile that is animatable is currently flashing, including some like that little, like the doors and treasure box that I'd rather not be animating. But that's actually a good kind of problem to have. Collision detection is not there. Other characters are not there. But there's a lot going on. A lot of good things here. So I'm going to talk about what I had to do to get to this spot. Flip over to our tiled map. In the title program, you can see it. This is the town map that we started with from the examples in the Like asset folder. And it has two layers. You've got the tile layer, which is sort of a base layer, and then you have one labeled sprites, which is basically it's the sprites, and it's some decorative tiles that sit on top of the base layer. Anything that has transparency, and you stack them to get the whole picture. And you can also see there's like so many tile sets here, which is a problem because the way it's implemented in the MiniMicro, you can have one tile display associated with one tile set, which means that this map would require two displays allocated for it in order to render, and that it can only have two tile sets. And I spent a lot of time trying to figure out how to get around that restriction. And what I finally settled on was building a master tile atlas, basically. So yeah, took all the tiles and meticulously copied and pasted all the files into one giant file. One for the base layer and one for the decoration layer. And if I need more tiles in here, I'll just expand the image and dump more tile images into it. But the way it works is like the deco TSJ file is associated with deco 0 PNG. Go into the source folder, assets, images. You see there's a deco 0 and a deco 1. And we accomplish the animation by flipping between these two. So, to get the town to work, I created a new tile map of the same size with just those two tile sets, and I went through and meticulously redrew the entire tile set. It's a little bit different. We have our base layer, we have a decoration layer, and we have added an entities layer, which is it's an object group instead of a tile layer, which allows us to like place objects on the screen, give them different properties. In this case, the only one I've implemented is like where the player is going to be. With an X and Y position, we can stick some custom properties on there, which we're not doing right now. But we could if we wanted to, and we probably will soon. And I had to make some changes to the title map. I also had to make some changes to the mini script library, which we will get into now. One of the problems, if you remember from last time, is that trying to render the town gave us some weird graphics artifacts. There is a bug in the layer display, which is kind of neat. You can see here that there is a -1, and I left a little note here for myself. That is actually a bug, because the -1 is associated with the first GID value in the map. Basically, each layer has a tile offset, so each tile can have a unique number. And I'm going to show you that file. It's actually not that hard to parse. Now in version 2, it's a JSON file, but you have the layers, you have the height of the map. What matters here is the tile sets. If you scroll down, we have two tile sets, the base and the decorations, and each one has a first GID. And you have to subtract whatever this number is from the first GID to get the actual tile offset in that tile set. And in the first layer, that number is 1. But in the second layer, the number is much bigger, so you just have to account for that. So I had to do some work here to grab that first GID and bubble it through all the layers of the library. And I think at some point soon we're going to go back and write that a little bit better, but that does give us access to the value. And that's what allows us to have multiple layers with 2 different tile sets. But I also added support for the object group, which was not there before. The object group, if you come down here, you can see there's our entities layer. And it has an array of objects. You know it's an array because of the square brackets. It's how you open a JSON array. And then you have the curly brackets for JSON objects. And it gives all the properties of whatever object I placed on there. Name, type, X, Y. So I'm just going to quickly go through this, but the source code will be available if you want to see it. I think it's at the bottom. Basically, we're parsing out the objects, searching for that layer with the typeset object group, and then it finds it, then it loads it with the tile object group loader. And you can see here you pass in the layer from the JSON file, pull out the properties we care about, parse the objects out. The object parser tosses those into the titled object class, which then also just copies the properties over. Did that, added a couple of functions here to get something by name. We can get the object by name because we named it player. And in the same way, tiled level, there is now a get by name to get the layer by name. So, with all of that done, we can now, if I find the player data, some of it's right here, but here, there's our tiled level. Get the entities layer by name, then get the player by name. And that will finally, after all of that, give us our player data, which we then need to transform. And that was a little bit tricky because the tiled level is calculating pixel coordinates. Top left is 0, 0, x is 0, y equals 0. Bottom right is, I think it's like 320 by 240. X is 320, y is 240. Now that's a little bit tricky because, like in the tile map, y is 0 at the top, 240 at the bottom. In the MiniMicro, it is 0 at the bottom, 240 at the top. And so this one thing we have to do is transform the y, basically invert it. Which brings us now that we get the tile height. It's like the height in tiles. It's 15 tiles, I think. The tile size is 16 to convert it into pixels. And then you also have to multiply by the render scale. So we take the initial x and y values, multiply it by the render scale, invert the y, offset by the player's physical location on the screen, which is like the player is centered, and then add a little bit because of like basically you can see I dropped the player object here. The coordinates are the center, I think. So we had to offset by half of a tile to get everything actually centered. And then rather than moving the player sprite, you actually want to scroll the level for everything to render in the right place. But once that's done, that gives you all the transformations you need to actually scroll the map to the right position so the player looks like here. Let me show you. So we can grab this player object now and move it wherever. If objects are moved around with pixel coordinates, I think if you hit control, it snaps to a tile position. So let's move the player onto this chair. The player can sit down for a bit. Rerun. And there we go. Player is sitting down in this little cafe. Isn't that nice? And let's see. Cleaned up the code a little bit. The the level actually has a scroll by method. I was scrolling each layer individually. This will handle it for us. There's a scroll by and a scroll to. Scroll to takes absolute coordinates, moves to next in Y position, and the scroll by just needs the delta. How much have the X and Y values changed? Oh yeah, to explain the animation loop. So we were animating the sprite manually using one of these animation blocks. I took that out when I passed that to the sprite controller and we put it back in for animating the map. I'm sort of cheating to make the animation work. He's flip-flopping. Open, close, open, close. Basically, we have our two images. And if we zoom in on, where's the doors? Down here. Deco 0, it's open, or it's closed. And Deco 1, it's open. So we just need to flip-flop between 0 and 1. And you can see that here, I'm loading both of those images and setting a flag for which one's active, starts with 0 being active. And our animation timer. The last time I animated was at 0 seconds. And at the current time, minus the animation time is greater than or equal to the animation speed, so it's going to animate at the same rate as our sprite. Then add 1 to the active animation layer, do the modulus so that it wraps back around to 0 when it gets the number gets too big, and then reset the tile set on that display. Layer 1 is the deco layer. Grab the display, grab the tile set, reassign it. Ta-da, we've animated. I'd like to be able to support the built-in animations with the tiled format, but that will take a lot more work. So, maybe next week. And I want to take a few minutes to actually clean up some of this code while we're all here. this code is getting bigger, and like this is actually getting too big. I don't like any file to be longer than 100 lines. It's just a thing. Some of the obvious things we can do. First of all, I want to start sticking the source code for this product specifically inside a source folder. And within that, so if we're going to have a source folder, we need to add that as an import path. And then we can start basically chunking these things out. Create something for our constants because we have so many constants to find. I think we have some more down here. And now that I've dumped those in there, everything's going to click. Because when you import constants, it dumps it all into the constants namespace, a constants map. Maps namespace is basically the same concept here. So I'm trying to remember exactly how to. I think there's a way to dump all that into global namespace. I'm trying to remember how. You know, I'm pretty sure we can just do this. I am almost positive there's a better way of doing this. But let's see if that worked. And, you know, it still works. So, good. Let's see if we can get this under 100 lines before we're done. Let's do the same for the spreadsheet. So that pulls the spreadsheet out, which still works. Make not found in map, line 68. All right, let's see what we forgot. Hmm. Yeah, it's still there. Spreadsheet is defined. There's make. No, I'm not entirely sure what I did wrong. So I'm going to cheat just a little bit. Look at the micro hack code that I've already solved this problem in. There's a couple of ways to do this. Let's see where the ensure input is defined. For util globals dot. I'm just going to grab those two methods. So doing that, we have this ensure import, which should import the module into the global namespace. I think I'm actually going to use this require method. Okay, here's the plan. Gonna have this module return the spreadsheet class. Do a require on that file. It basically works the way some other JavaScript programs work. Returns it, assigns it to the spreadsheet in the global namespace. See if that gives us the result we want. Line 1, too many arguments. Oh, run. There we go. That works. Are we under 100 lines yet? No. And it might be too much to ask for today. But last thing I want to do today, while we're here, is clean up this transformation code a little bit. If I can find it, this transformation code, because we're going to stick a bunch more entities in the map, and it's not going to do to redo this every single time. So the way we do this, I'm going to move all this math up to another function, probably after this video is done. So first of all, I'm going to automate the scaling. Make sure it still works. Check each step here. See, that didn't work because that's not how you define a function. Do it like that. Talk about JavaScript and then I start writing JavaScript code. Okay, so that still works. Invert the Y. There, just make a translate function next. I'm just going to rely on duct typing to make this work. As long as both objects have X and Y properties, that's really all we care about. And since we're just returning the original point value, it's going to be the same type of object. There's not really a simple way of inverting that. See, what I wanted to write is this, but that's not going to be a thing. You can't just negate an entire map. Should be able to do that. Just uglier than I wanted, but there you go. We'll clean it up a little bit more later. And I'm going to basically do the same thing here, since I don't have a better way of representing this yet. A way of representing this in the near future. Set by that half tile. And there you go. It it still works. So the trick here, we still need to wrap all that up. What I want to be able to do is throw in the tiled object, the player data, and have it spit out something on the proper scale. Uh, I think this one actually has to be the player sprite, because that's the actual render position. yeah, we'll have to come back and test this when we have more than one sprite on the screen. Type error. Line 153, it looks like. 153. Oh, it's because we are not returning our player data. Although, we don't necessarily have to. I don't think. I think that will mutate the original object, but make sure. Yeah, okay, so we don't have to return it. Yay for mech mutation. So let's get all of that code out of the way. Converting tiled pixel coordinates into MiniMicro coordinates. And so we have all those math functions. I think I'm going to leave them in the math namespace. And the way that works, so import math. And down here, you have to type in math.transform tiled object. And there you go. It's visually it's the same code, but it's a little bit cleaner. The file's a little bit smaller. We started breaking up the code into logical files. Still hoping I can do a little bit more work on tile animations, which will probably mean modifying the base library some. And of course, back to our original problem, we're wanting to get all these other characters into the map. So, yeah, I'm going to stop it right there today, and hope to see you all again soon. Thanks for watching.